Welcome to this tutorial on using the Cycon machine learning tool for predicting energy consumption with the AdaboostRegressor. In this walkthrough, we will delve into a real-world energy dataset and demonstrate how to apply ensemble machine learning techniques to build a robust regression model. We will learn how to handle categorical data, prepare it for training, and apply the Adaboost algorithm effectively. Whether you are new to machine learning or looking for refine your skills, this tutorial will help you understand the key steps in building and evaluating a predictive model using boosting strategies. Before we dive into the model, let's revisit the concept of multivariable regression. This technique is used to predict a single continuous outcome based on multiple independent variables. It allows us to understand not just how each factor individually affects the outcome, but also how they work together. For instance, in our dataset, variables such as building type, number of occupants, and appliance usage all potentially influence energy consumption. By using multivariable regression, we can isolate and quantify these effects in a statistical way. This is a fundamental tool in many fields, including economics, environmental science, and engineering. The dataset we are working with consists of 1,001 rows and 7 columns, capturing various characteristics of buildings and their energy usage. Some of these variables are numerical, such as square footage and number of occupants, while others are categorical, like building type and day of the week. Machine learning models require all input features to be numeric. So, one of our first tasks is to pre-process data by converting categorical variables into numerical formats. This ensures capability with algorithms like Adaboost, which expects input in numerical form to calculate splits and making decisions. After identifying the categorical features, such as building type and day of week, we use encoding technique to convert them into integers. This transformation assigns a unique numerical code to each category. For example, residential might be coded as 0, commercial as 1, and so on. This process is essential for allowing machine learning algorithms to process and learn from these variables. Encoding not only helps the algorithm interpret the data but also enables consistent model performance, especially when we use tree-based method that split on numerical thresholds. Now let's talk about the heart of our tutorial, AdaBoost regression. AdaBoost, short for adaptive boosting, is an ensemble machine learning technique that builds a strong predictive model by combining several weaker learners. Typically, these are shallow decision trees that on their own may not perform well, but when combined in a sequence, each one corrects the mistakes of the previous ones. The algorithm place more emphasis on data points that were predicted poorly in earlier rounds, essentially boosting their performance for subsequent learners. The final output is weighted sum of all these weak learners, producing a robust model that often performs well, even on complex datasets. It's particularly effective for regression tasks where traditional linear methods may fall short due to non-linearity or interactions among features. With our data pre-processed, we split it into training and test sets, 80% for training and 20% for test. The AdaBoost regressor is then trained on training set, learning to minimize prediction errors through its sequential correction mechanism. Once trained, we evaluate the model using the R-squared metric, which tells us how well the model explains the variability in energy consumption. A higher R-squared value indicates a better fit. This final step helps us assess whether our model is effective and whether further tuning or additional features might improve its accuracy. Encoding, model selection, training, and evaluation all work together to form a complete predictive workflow. Now, let's walk through how to use Scikon ML AI web application to perform the AdaBoost regression task. Here, we start with the proper name of this project, and then we add the description of this project. In the data type selection, we select tabular, since our data is in CSV format, and then we click Upload CSV button, and then we click this button to upload our CSV data. After successfully uploading our CSV data, we can see on the right side of this application we have Table tab and Data tab. On the Table tab, this is an overview of our dataset. It has all the columns of this dataset. And if we click the next, it's going to go through all of the rows of this dataset. On the Data tab, it has 3 types of information: the new instances of the data, the data types of each column, and the unique values of each column. Now let's continue. In the pre-processing section and the target label section, we click the last column, the energy consumption. This is the target we want to predict. And then we choose the machine learning algorithm method. In the algorithm class section, we choose our AdaBoost regression. And then we choose our evaluation metric, which is the R-square. Here we click the Perform button to get the result. As we can see here, the R-squared score is 0.91, which is very good. It means we have a very accurate prediction. This plot is a 2D plot for one-dimensional input and one-dimensional output. Since our task is multi-variable regression task, this plot does not work well, but it works very well for 1D input and 1D output. And if we scroll down of the result, we can see 2 tabs as well. And if we scroll to the right side, we will have the details of our prediction. The y-test is the ground truth of our dataset, and the y-predict is the predicted value of our dataset. You can see these values are very close. And this has been our tutorial for AdaBoost regression model. Thanks for watching.